All right, well, welcome everybody to the very first presentation from the Research and Thought Leadership Initiative within the Innovation Committee of the Infrastructure Masons. Just a couple of things quick before we jump right in. Next slide, please. Typical house rules applies as goes for all Infrastructure Masons meetings. We are all here to connect, grow, and learn from each other. We're very graciously joined by Matt Crozat from the Nuclear Energy Institute, who's going to be presenting. We are opening the floor for questions at the end of the presentation, so please do feel free to add those to the chat on the side, and we'll hit those as best we can at the end. Next. Little bit more about the Research and Thought Leadership Initiative within the Innovation Committee here. Our goal is to identify topics of interest for the industry, connect with experts like Matt in their given field, plan presentations like this, and increase awareness on those topics to help the industry really set a baseline level of information. There's a lot of vendors, a lot of hype, particularly around topics like this, and our goal is to cut through that and get you all some real information. Next, please. And if being involved in initiatives like this are of interest to you, we are still looking for additional members of this group, as well as other initiatives within the Innovation Committee. We're not looking for a massive time commitment here. If you are interested, we've got some upcoming topics and presenters already identified on topics such as process-specific chipsets, green hydrogen, using AI to accelerate data center construction, green concrete, and many others. So if you are interested, please do reach out either via the Engage platform or to myself directly. If you received an email with this invitation from Romain, you can reach out to him as well, and we will make sure to get you all engaged. Next, please.
So this has been a passion of mine for the last year, and I believe personally it's the right way forward. As evidenced by a survey in the recent Virginia iMasons members meeting, power availability is a #1 concern in today's market. As developers and data center operators search for larger sites with increasing density to meet AI and cloud demand, the desire for carbon-free, reliable energy has reached insatiable levels. Providers of advanced nuclear energy generators in the UK and the US argue that nuclear provides carbon-free energy, which must be a part of any plan to decarbonize society. These smaller reactors can be built repeatedly using factory-made components, and with this approach, it is hoped that the planning and approval process for nuclear can be made shorter by this level of standardization. Even hyperscalers are looking to hire principal program managers for nuclear technology, specifically to lead the company's technical assessment for integrating small modular and microreactors to power the data centers that the cloud and AI reside on. The iMasons Innovation Committee wanted to bring an expert to shed some real light on the subject, and have partnered with Matthew Crozat, Executive Director of Strategy and Policy Development with the Nuclear Energy Institute, or NEI. He is here to share the status of nuclear and the future of clean energy. Matt is responsible for directing NEI efforts to identify policy initiatives that will improve the economic viability of operating plants and for new plant construction, and examines the market operations and proposed policies to assess their impact on nuclear energy. He also oversees analyses for nuclear industry cost performance and trends. Before joining the NEI in 2015, Matt was a senior policy advisor in the Office of Nuclear Energy, the US Department of Energy, and is recognized as an international expert on nuclear economic issues. He served as co-chair for the Working Party on Nuclear Energy Agency for over 10 years. And with that, it's my pleasure to hand you over to Matthew Crozat.
Thank you, Jansen, and thank you, Eric. It's my pleasure to be here. I think as a way of starting, though, I should probably mention a little bit about who NEI is and what we bring to the conversation. So the Nuclear Energy Institute is based in Washington, D.C., and we are the trade association for the nuclear industry. Our members include companies that own and operate nuclear plants, those that design them, build them, maintain them, lawyers who license them, universities who provide the workforce for them. And we serve as a unifying voice for the industry in policy conversations and regulatory conversations and in public outreach as well. So in that regard, I'm really pleased to be here and have the opportunity to speak with this audience. In talking with Eric and Jensen in advance of this, there were 5 areas that we thought would be worth touching upon. I'll go fairly quickly on the hope that at least in time we can go back and revisit some of these topics along the way. First, I want to begin with the interest that we're seeing in new nuclear technologies and what form that's taking and the basis for that. I also want to talk a little bit about public perception for nuclear energy. This is a common question that we get, and I wanted to at least have a framework to address some of those questions as well. I also want to get into a bit of the technologies themselves, at least to provide a sense of the range of possibilities that we're seeing and some of the business models that are being currently developed that are somewhat novel from our industry. I'll talk a little bit about the regulation that these technologies face and kind of our engagement in that process. And finally, some of the applications that we're seeing that are beyond the traditional uses of nuclear. And with that, let me begin with just a way of framing kind of what we're seeing today as far as the conversation around new nuclear. I mentioned that our members include those that own and operate nuclear plants. We asked those chief nuclear officers of those companies, those who already have nuclear energy, what they saw as they looked in their plans going forward. And we really wanted them to think about the modeling that they do for their future scenarios and how nuclear fits in that context. And what they told us was 2 big things that began to really quantify some of what we've been hearing anecdotally. The first is around the fleet that we have today, which is right now we have 93 units that provide just shy of 20% of electricity in the United States. Just about all of those units have been renewed for a second license to operate for an additional 20 years. They were originally licensed for 40. They've almost all received a license renewal for 20 years. We expect that just about all of those plants will continue to pursue a subsequent license renewal to go to 80 years, which would take just about all of the current fleet to a licensed lifetime into mid-century. We have seen plants close along the way if they had an operating license, so that's not exactly a guarantee of operation, but is a necessary step. And I think it speaks to the kinds of expectations that we're seeing from these companies that are facing obligations to provide carbon-free generation into the future, which is you begin by holding on to the carbon-free generation that you have. But beyond that, we also began to look at a future in which they're expanding their nuclear capacity to roughly 90 gigawatts of new nuclear, which is roughly what we have as the operational fleet right now. So in the United States, we're talking about a doubling of the fleet just from those companies that already have nuclear in operation. If I think about this in terms of some of the small modular reactors, just to quantify, that's something on the order of 300 new nuclear units added to the system. Just for reference, historically, the United States has approved something on the order of 140 units in our entire nuclear history. So we are talking about a phase change of the style of deployment and regulation that we've experienced in the past. What's behind this? Well, I'm not going to go through all the points on this slide, but what we really want to focus on are the second and third ones here, which is the ability to pair a 24/7, round-the-clock generation asset that is carbon-free alongside wind and solar that are being deployed at large scale. We continue to expect that we're going to see an increasing drive towards low carbon solutions, but nuclear works really well as a complement to provide this steady power alongside intermittent resources that are been expanding widely and will continue to do so. This is happening with the backdrop of a lot of political support across the aisle. By way of full disclosure, I'll point out I made these slides a number of weeks ago, and the politics have been evolving since. But the overall themes here from the Biden administration, Republican Congress, even the chairman of the Senate Energy Committee, have been very strong support for nuclear across all of these political constituencies. And this is actually driven to a manifestation in some pretty significant policy developments over the last 2 years that have really reshaped how nuclear could fit in the portfolio. Going back to 2021, we had the bipartisan infrastructure law, the Infrastructure Investment and Jobs Act. This was passed on a bipartisan basis, as I said. It included 3 big policies for nuclear. One was funding to ensure that plants that were facing the economic pressures to close would have funding to continue operations. That funding has been central in seeing the decision to reverse the planned closure of Diablo Canyon in California, for example. We also saw funding for the demonstration of advanced nuclear technologies, which had been previously identified, but now actually have the money to go with the government cost share. And I'll get into more of that later. And finally, funding to really promote the use of low carbon hydrogen to allow these technologies to create a footprint in non-power applications. So really, to my mind, into industrial and transportation sectors as well. And nuclear was part of that also. About a year later, we saw that a second big policy passed. This was the Inflation Reduction Act. This had some pretty dramatic signals as well. We began to see not just this DOE funding program for continuing operation nuclear plants, we saw a tax credit, which is a lot easier for companies to plan for. We also saw tax credits that brought nuclear in parity with wind and solar and other renewable technologies to promote their deployment, either in the form of production tax credit or investment tax credit. We can get into that later if you're interested. The key thing, though, is for the first time, we began to see nuclear elevated to the same stature as some of these renewables in the tax code in a way that just focused on the carbon-free attribute, regardless of the technology. And finally, we saw tax credits for clean hydrogen production as well, that nuclear stands to be eligible for. Taken together, we see some very powerful policy signals saying nuclear needs to be part of the portfolio for a low carbon system going forward. And to that end, we have seen this broadened support. This is the policymaking level. Those of us who've been around for a while have seen the conversation around nuclear take a number of different forms, not all of them constructive. I like The Simpsons. I will point out that using that as a term of reference for thinking about the role of nuclear technology and safety is not the best basis. But we have been trying to get our arms around what the conversation really feels like today. To that end, we've seen a lot of surveying going on. I want to focus on one that was done recently from a group called Potential Energy. This was really built from a expertise looked at brands management and testing with a global focus. And I think probably the largest survey of attitudes towards nuclear energy that we'd ever seen across 8 countries, including a large oversampling in the United States, to get a broad sense of expectations around how advanced nuclear was being perceived widely. Here's some of the results. First, what we begin to see is as we ask people on a 5-point scale how they look at nuclear, the answer is positively. I think in some cases surprisingly so. We begin to see, even in countries that have been more reticent towards nuclear in recent years, we see support, at least modestly so, for continuing role of advanced nuclear. And in some cases, we've seen extreme strong support for nuclear. If we take that same kind of question and push people off of a 5-point scale and simply ask them, should nuclear be part of the future or not? The answer is yes. we see strong support for nuclear as a policy choice for moving forward technologically. Even when we begin to narrow the question for those who claim a affiliation with an environmental organization, we see support for nuclear across countries. Moving past the point, especially in the United States and Europe, where nuclear was being seen as the primary focus for environmental activism, that's been softening for a number of years now. And we're really seeing it in the data. I'll come back to that too. One of the places we have seen a gender gap is around support for nuclear. Upon further investigation, though, what we're finding is this gender difference in how nuclear is being perceived is less about a rejection of the technology and more about an uncertainty. There is an opportunity for engagement and conversation to bridge this previously established gap that we have seen. Some of the data that is not included here shows that just creating a conversation around some of the attributes of nuclear goes a long way, even in just the brief context of an interview, of moving some of these attitudes, which is something that's encouraging as well. I mentioned the cross-party support for nuclear in the United States. That's not just an American phenomenon. As we look across parties in many of these countries, we see broad support for nuclear. Where we're seeing some of the nuclear challenges in policy space is places like Germany and Japan. You have had a coalition of parties that do have a mild bent towards anti-nuclear policies, but even those aren't extreme. And those are more exceptional than what we see more in the broader subset of countries sampled here. The fun thing I'll point to is where we are seeing the strongest resistance to nuclear. And that has tended to be in older populations in some of these countries, especially with particular histories with nuclear. What this finding, I think, fits alongside of is what I've seen over the course of the last 5 years, or I said anecdotally, which is that the way younger generations have viewed nuclear is not as the same way that it was defined in the 70s and 80s in particular. But to put it clearly, climate change is a bigger concern than anti-nuclear activism assumed 30 or 40 years ago. And we are seeing this in not just the survey data, but in the kinds of conversations that we're having and the sort of political support that we're seeing as well. A very interesting development that happened, to my mind, fairly quickly over the last 5 years. But part of what's been driving this conversation as well is that we've had the chance to open up what nuclear means. That we no longer have to think about nuclear as the same specific projects that led to anti-nuclear activism in the 70s and 80s. There are new ideas, new possibilities, new technologies that have really given an opportunity to revisit some of the questions around what nuclear can mean and how to think about them more holistically. The advanced designs have gone a long way towards opening this conversation. So let me talk a little bit about those. I want to begin by acknowledging that in the United States, we are seeing the first Generation 3, as we call it, nuclear plant online. Unit 3 of Plant Vogtle in Georgia is operational. Unit 4 will follow within about 6 months. This will provide enough carbon-free power to run about 1.5 million U.S. homes every year. It didn't go according to plan. It was a bit more of a journey than we expected, but the persistence that led to this creation, this completion, has created the learning that will inform all of the technologies to follow. All right, so where do we stand today? We're looking at something on the order of 6 technologies being developed. It's not the same degree of maturity. I'll talk a little bit about that in a moment. We're seeing the Department of Energy with significant funding to support the development and commercialization of some of these designs. Utilities are including these technologies in how they view their long-term plans for how they're talking to their state regulators for what they need to be building. In particular, we've had a growing interest in the possibility of putting nuclear plants where we had previously had operational coal plants. It turns out the physical infrastructure is very similar. The workforce needs are very similar. There's a lot of political support for this one. And as I mentioned, Congress has been very constructive in the conversation recently. What's driving this? Well, by looking at smaller designs, we're opening up the possibility for changing both the machine itself and how we build it. So essentially, by having smaller cores, we have simpler designs that rely more on natural phenomenon for safety of operations. So more reliance on passively safe concepts such as natural circulation, which simplifies the safety case behind these plants, and also should minimize the requirements that they need to fulfill to be demonstrated safe for deployment. Also should enable a change in the model of how we build them. More factories, move faster, the economies of replication as opposed to economies of scale, lead to cost competitiveness. What we see here is a sampling of the kinds of companies that are developing these technologies. Some of these are old stalwarts of the nuclear industry, like a Westinghouse or General Electric. These have been companies have been part of the nuclear enterprise since it was founded. But what's also interesting are all these other logos on the page. For the most part, these resemble more of a tech startup philosophy as opposed to government contractors. We are seeing what I think for the first time I would call an entrepreneurial nuclear development system, where you have companies being founded out of small founders that are going for venture capital funding and eventually IPOs to develop the technology, while also doing it in a way that's not beholden to the larger bureaucratic infrastructures that we've seen in the past. Not all of these companies will be successful, we know that, but it has opened up the possibility of the kinds of ideas and the kind of talent coming into the industry that we'd ever seen before. This is unique to the United States as well. We haven't seen this scale of entrepreneurism in nuclear development in any other country either. So what are we looking at is time horizon? We have a series of designs that are working to various stages of demonstration, either in concert with the government or just on private schedules alone. This will be a real opportunity to see actual dirt moved, concrete poured, and power produced this decade for a number of designs. And I'll talk about some of these in a little more detail. But I do want to get a little bit technical for a couple seconds here, just to talk about the range of technologies that are coming to the marketplace. Everything in the United States right now is a design cooled by water. So in the bottom right hand, water is easily available. We have its properties, it's a great idea, and it will continue to be a lot of designs going forward as well. But it has some limitations. Because of its boiling point, it needs to be kept under pressure to really maximize the thermodynamic properties to produce electricity. It also minimizes the temperature of operation. As we look towards other coolants, many of which have been tested in the past, but never commercialized at the scale we're talking about now, you open up the possibilities for what these technologies can do. You can either have designs that have less need for high pressure containments, which are very expensive, or can operate at higher temperatures, which improve thermodynamic efficiency and also open up different business lines. As I look at some of those companies from before and put them on this chart, we're seeing a range of technologies and designs coming to the marketplace that are just much more vast than we'd seen prior to this development. Until recently, if you looked at deploying new nuclear energy in the United States, everything was in the upper left-hand corner. It was big and it was water-cooled. Now we're seeing much broader range in terms of the sizes of the units and also the technologies that are being deployed as well. So let me give you an example of what one of the more straightforward extensions looks like, and that's GE Hitachi. They have a 300 megawatt boiling water reactor. It builds heavily upon a design they developed the better part of a decade ago, which was much larger, but it relied a lot on some of the kinds of passive systems to ensure safety. So a lot of natural circulation involved in the design. That was all has gone through the approval of the Nuclear Regulatory Commission to establish the safety of these concepts. They have much longer periods for ability to withstand challenging operations without any operator actions. Interestingly, they're also trying to lean heavily upon new construction techniques to the nuclear industry, leaning heavily on techniques that we've seen in things like drilling technologies that have been previously used in, say, the oil and gas sector. They also build upon fuel that we have a great deal of experience with, so that's well understood and well established. We're seeing interest in this technology from a number of U.S. utilities, but most notably the Canadians in particular have committed to deploying this in Ontario this decade. So very much a technology that we're excited about. Another possibility along these lines in the light water SMR is NuScale. Their design is a different concept. They focus on what they call a power module, 77 megawatts, and the ability to put multiples together in one facility. This has been through the NRC technical review, so this has been approved. It also, in so doing, has been granted the regulatory change that rather than needing to create a 10-mile radius for, in the case of an upset condition to manage the population, the expectation here is that this plant would never have a radiological release that would ever leave the site boundary. In other words, I don't need to worry about how this interacts with the local population. Nothing's ever going to get that far. And the NRC's approved that concept based upon these smaller designs. Also uses existing fuel. I'll come back to this at the end as well. As we get a little more afield from the current range of technologies, I want to point to TerraPower, which is developing what they're calling the Natrium system. This is a sodium-cooled reactor that has this very interesting characteristic that is designed for the reactor to operate at a constant power output, 350 megawatts, 345. But it's linked to a storage facility, a thermal storage capability that can ramp as high as 500 megawatts. So if you're putting this in an area where you have renewable deployment nearby, it has the ability to store its extra power when I have the solar output or wind output and save it for when that's not available, at least at that point. This is a company that's been backed by Bill Gates and has seen funding from the Department of Energy as part of its cost share. It is being developed in Wyoming to replace a coal plant that is going out of business, and the overall response from the communities that were not selected has been to plead for additional units. So they're exploring developing more of these in Wyoming to replace coal facilities in the state. So that's kind of a flavor of some of the technologies. I have a couple more that I'll come to as well, but I want to talk a little bit about regulation and applications and then open for questions. So one of the places to start when we think about safety regulation for the nuclear energy in the United States is we're starting from an incredibly strong position. The nuclear fleet of reactors is among the highest in occupational safety anywhere across the economy. We have an independent regulator that is largely paid for by the industry itself. But they are independent and overseen by Congress. And so we spend a lot of time interfacing with them to ensure that the kinds of things they're working on are the ones that actually improve safety and not just create administrative burden. As we look towards these advanced technologies, this opens up, I think, additional possibilities that as we incorporate more and more of these safety features from things I've mentioned, like natural circulation, it should make the case for establishing safety easier. I think right now we're still working through the first units, and there's been a lot of back and forth. It's been a lot more time consuming than I think we'd like. But the hope is that once we've worked through these issues, we'll have a strong basis of precedent that we can refer to as we look to deploy subsequent units that can more easily incorporate what we understand from the science and how it's already been established in the technological basis for regulation. So we expect the first movers to have more challenges that should be then paid off in the longer term by having a more well-established basis for more efficient approvals going forward. That's the theory of the case. We have a lot of things that we focus on to try to ensure that we're working towards that goal. I'm not going to go through all of these, just to point out that we have the basis right now to license the plants that we are designing today. What we're working towards is ensuring that we can streamline that in a way that safety is being preserved, and we don't have to do so in a way that is administratively so cumbersome that the 20th unit feels like all the same amount of questions as the first unit, in spite of the fact we answered all those ones already. So that's kind of the regulatory framework. We can go into more of this if we like. I want to talk about applications, though, because one of the things that has been really fascinating in the last 4 years is we've seen that as we've expanded the portfolio of technologies that are available, we've also begun expanding the kinds of companies and industries that are interested in nuclear for their own opportunities. Some of this has to do with the sizing alone. Others have to do with the temperatures as well. So let's talk about some of the sizing. We have reactors that are being developed for as small as 1 megawatt. But for a comparison, Vogtle 3 is 1,100. What we're seeing is a great deal of interest around being able to use these smaller units at more physically removed locations, both in terms of the geography, but also for applications that might want to, say, remove themselves from integration with the broader bulk grid. So we have technologies, in particular, I'll point to Oklo, which is probably the furthest along in commercialization of these technologies. It's looking at, it's calling a fission battery, the Aurora powerhouse. It's a different design. It's dead simple. It's built on concepts that were developed in many cases 40 years ago, but again, never commercialized in quite the same way. The idea here is that you'd have a system that's fueled to run for a decade, and it'd be just swapped out after that period of time. We have expectations for demonstrations in the next few years. This company is actually going through a SPAC right now to go public, being led by Sam Altman, who's a leading investor in the technology. So we're seeing, I think, additional applications for how this might fit. It's not designed to do the same job as a Vogtle 3 in the middle of a grid in the Southeast, but opening the possibilities of where nuclear might be deployable. I also mentioned temperatures. Here we're seeing the possibility that as we look at higher outlet temperatures, so we might see additional industrial applications. Essentially, there's only so much you can do if you're using a light water reactor as far as how high you can go. As you look towards liquid metals, molten salts, I can raise those temperatures quite a bit to become more interesting for broader industrial uses. We're having a lot of conversations with the oil and gas sector that didn't make a lot of technical sense before, because I have concepts now such as the X-Energy XE100, which is not 100 megawatts. I've never understood why they call it 100. Different question, though. What is interesting, though, is by using a fuel that's been well researched and developed by the Department of Energy over a number of years, but not commercially deployed at the scale, it can operate at higher temperatures using helium as a coolant instead of the current design that we've seen with water. With these higher temperature applications, you can think more broadly about industrial uses. That's exactly what's happening as Dow has come on as a major partner. They're looking to deploy this technology at a petrochemical facility in Southeast Texas called Seadrift, with the intention of replacing what is currently fossil fuel going in for process heat, instead using just the heat application from these technologies to operate this facility. Again, broaden the perspective. So, and sort of begin to wrap up and open for questions. As we've looked at these sizes that have changed how we look at what's possible, and then the markets that we're seeing as well, one of the places I didn't talk to yet, but I'll close on, is we've seen a lot of direct engagement around the use of nuclear as part of a solution for large data operations. We have currently at one of our nuclear sites today, a data center that is operating behind the fence line, drawing power directly from the nuclear units for a carbon-free solution there. We're also seeing conversations with companies that are looking at these new technologies and the extent to which they might fit as part of a solution. NuScale, I mentioned earlier, is exploring the possibility of a large set of deployments for data centers, I think, in the Ohio geography. We'll see how that plays out. All of which to say that we've coming to a point where the commercialization of these technologies is opening possibilities that are just broader than before. Also at a moment when what the nuclear technology provides in terms of a round-the-clock, reliable, carbon-free asset is being increasingly valued in the marketplace. And so that's why I think that, as Jansen said, there's a real excitement and enthusiasm about how this fits alongside other technologies that are going to be of interest as we look towards what the energy needs have to look like as we go forward to the next decade and beyond. But with that, let me stop there, open up to some questions, and have a bit of an opportunity for some dialogue here. Jen, should I turn to you?
Appreciate that, Matt, and thanks for giving us the breakdown on where we're at in the market currently and kind of how we got here. I think for the data center market, one of the primary questions most folks have, and there might not be a very easy and straightforward answer, is when can this industry start planning around SMRs as being a power solution for sites that we're developing? We see that initial deployments are projected to come out in the 2027, 2028, and those seem to be proof of concept, test cases, partnerships. But in terms of commercially available power, when should we be thinking about nuclear small modular reactors, advanced reactors as a solution?
So I think when I look at the projects that are coming on towards the end of the decade, those are going to be, in many cases, full-scale, commercially operational units. So what you're seeing there is going to be what the next ones look like, which is, I think, opens the possibility for some pretty quick, fast follower options. As you look towards more aggressively technologically innovative designs, in particular some certain kinds of fuels, those might be a little bit later, as I think of some of the advanced designs that don't have the same kinds of regulatory experience with novel fuels. But I think as we look towards these small reactors, what we're seeing is I have a great deal of pent-up interest in utilities that want to go forth. Where I think there's a real opportunity, and where I think some of the non-traditional companies can really have a real role, is in targeting those second, third, fourth units and being partners in those projects, of showing there is an interest in accelerating this beyond just what utilities are in position to take on. One of the things that we're seeing is that these companies that are in the utility industry, they have very conservative management philosophies, because that's what they are required to do under state regulation. Part of why I think there's an opportunity is to think more broadly about who's developing these projects and what their risk reward calculation could look like. And I think there's, in my mind, opportunity for a way to really accelerate the deployment of these technologies by seeing partners come in who can help to bolster the confidence of otherwise reticent companies that who know they're going to do it, but trying to wait until they have the regulatory head nod that I think will, in some of these cases, be a little bit slower. Technology will be there. I think it's trying to ensure that you have a deployment window that meets the needs of the customer base that's trying to take advantage of them.
So did I hear you correctly that the technology is vastly outpacing the speed at which our regulatory processes are able to adjust and adapt?
Regulatory, and also, but regulatory in two senses. There's the safety regulator, the Nuclear Regulatory Commission. And yeah, that's been a little bit slower than I would like, especially for things that are built upon an expansive amount of safety relative to what we've seen in the past. But from some of these state utilities, the kinds of companies that provide power in the Southeast, for example, they also have state regulatory relationships about ensuring the rates that they can charge to the customers. And they have to be very conservative in how they make risk calculations in that context. Where I think you've got some real opportunities here is that the ability to make the safety case for these technologies is, I think, very well positioned. You've already seen it with NuScale. The GE small modular reactor will be, I think, a very straightforward case, where I think that the rate limiting step right now is on, trying to create the conditions for the first movers to actually bring these things to market deployment. And that's where I think there's an opportunity.
That's great. We do have a couple questions coming in through the chat as well. First one, what safety parameters and protocols are being discussed for microreactor or SMRs after they've been operational? And there was a follow-up to that, safety and security being concerns there.
Sure. So all the plants that are operating in the United States have to demonstrate the safety during operation to the NRC. They have resident inspectors at every nuclear plant right now. And so in some regards, this is kind of a difficult question, because in order to get the license to deploy these units, you have to be able to demonstrate that the operation of them will be done in a manner that is consistent with the safety that's expected. A long way of saying that regulation doesn't stop when you build it. It actually, the construction is the pathway to when the regulation really kicks in, which is how you're going to operate it. And so much of the challenge in the building phase is that we're trying to make the operational conditions as streamlined and as efficient and as safe as possible. And so you have to demonstrate all of that before you build it, in order so that once you get to the point of the operational phase, the regulators are already in place to understand what the safe operations look like and how to then enforce it.
Appreciate that. Looks like we've got a couple hands in the audience. Brian?
Sure. Can you guys hear me?
Yes.
Matt, thanks for that presentation summary. I thought that was really good, especially on the public perception stuff. You used the phrase, how do we reduce the regulatory burden without reducing safety, or something to that effect. So I worked at one of the providers of both equipment at GE and at the biggest owner of nukes in the past. I'm a data center guy now, but it seems that a lot of the existing stuff is you got to jump on one foot, tap your head 3 times, and so forth. There's all this process and burden. Can we get better with existing stuff? And what's your view on, or the industry's view from where you sit, for the existing technologies, the existing plants and so forth? Are we sort of saying that's all got to go away over time and we're just going to focus on SMRs? Or do we still need some really big things to feed base load as we do much more, let's say, microgrids with SMRs all over the place?
No, those are 2 good questions. Let me take your first one on the challenges for demonstrating safety at the operating plants. So part of the challenge I think we have is, the way I think of it, a lot of the regulation was developed in an analog era because the plants were analog. And we had the classical dials and knobs and everything else too. And a lot of the ways that we can demonstrate that the system is working as intended is things like measuring that the backup system is ready to go when needed. Part of the thing that we're running into here is like, well, if I have simpler systems that don't require as many backup systems, how do I demonstrate that it's working when it's supposed to, when I don't even need the thing that I was measuring before, right? How do I demonstrate I'm not going to have a large pipe break if there's no pipe, which is kind of one of the real challenges we're running into. And so I think we're in this mode of trying to bring this analog system that we developed for the current fleet into a more modern age. And this is being done with a great deal of, I won't say suspicion, that's a little much, trepidation. And we're trying to create the conditions to demonstrate that we're not trying to compromise safety. No one in the industry thinks that a less safe industry is helpful. As a matter of fact, there's very few ways I can imagine completely bringing the whole future of the industry into a very dark place than having safety issues. It's ensuring that what we're doing to demonstrate compliance is actually ensuring safety. And I think we've gotten a little bit into the administrative burden as a means of demonstrating compliance. We got a little too far down that road. You also asked the question about the emphasis on small modular reactors and the role of the larger new ones. And I think that's a great question. Part of the reason why I think we've had this, actually not I think, I know we've had this emphasis on small reactors, is it turns out building big reactors has 2 aspects. One is they're very expensive because they're big, but also you need to have a lot of new power. And so as we saw the overall demand for electricity begin to flatten in the expectations over time, it used to be that you began to see a pretty consistent relationship between economic growth and power growth. That disconnected for the better part of the last decade and a half. And so it was hard to think in terms of needing to add 2,000 megawatts when you might only be needing 500 megawatts. And the small reactor began to fit that model better. As I look towards perhaps needing to more rapidly move away from fossil fuels, or if we believe some of the current thinking around what things like artificial intelligence might imply for demand or electric vehicles, I might be thinking in terms of adding thousands of megawatts instead of hundreds. And that might reopen this question very quickly of large reactors. I will tell you that as we have these conversations internationally, places like Poland and Eastern Europe, they want thousands of megawatts of new nuclear, not hundreds. They're looking to move quickly. And so I don't think this is an either or. I think it's trying to find the conditions under which the technology fits the market that you're trying to align with.
Thank you.
Jeff, see your hand up as well.
Yeah, thanks, Eric. And Matt, thanks for the comment. Eric, I want to mention that like perhaps this affects some other people. My chat seems to be disabled, or I pose my question in chat. I'm not sure why that is. But thank you all for hosting this. So I was disappointed to read the news recently about the collapse of the NuScale UAMPS deal. I wonder if, Matt, I wonder if you could comment on that. And I have another wildly different question that I won't use as a follow-up, but I'm going to put my hand down now. There you go.
Well, no, I appreciate that. I was anticipating this in the Q&A, so I didn't go back and rejigger my slides at the last minute. So for those who don't know, the project that was being developed as the first SMR in the United States was called the Utah Associated Municipal Power Systems. They're going to build a NuScale plant at the Idaho National Lab, which is just over the border from Utah, to go into deployment towards the end of the decade. They announced just last week they were canceling that project. There were a couple of things I'll mention about this. One was that it was always kind of a unique structure for how you might approach this kind of a project, and that the Utah power system was a coalition, essentially, a consortium of different, very small utilities in the Intermountain West. The problem with that, we have small utilities part of nuclear projects all the time. But the way this had to work was you had to have a certain number subscribed for out from the project. And this has meant that you had not one developer trying to lead a project. You had a whole coalition of folks trying to coordinate whether they wanted to move together or not. And in the end, they couldn't get enough folks in the same level of the headspace to move forward. It certainly didn't help that the cost of the project went up from when it was originally priced. It's interesting, though, because the day before this project cancellation was announced, I happened to notice in my feed a newsletter that I got from S&P that pointed to 4 different headlines about cancellations or write-downs from offshore wind that all had happened the day before. All these projects have been in common to my mind. These were all projects that were originally priced at a time when inflation was 0 and interest rates were functionally 0, and all got reassessed once those were no longer true. And I think that the macroeconomic context for some of these technologies will continue to matter. And I think ensuring that how nuclear is understood relative to other technologies is going to be an important part of how this evaluation goes forward. All these projects are similar in that they have a lot of capital-intensive expenditures upfront and are very cheap to operate. So I think this is going to be a common feature of the landscape we're looking at. It just is different when you thought you were getting into something when the cost profile is one thing, and it turns out you're going to find yourself at a different spot. This is, again, not just a nuclear problem. This is going to be true of all of these technologies as we go forward.
Appreciate that. Thanks, Matt. Yeah, GD.
Oh, is that me, Guy DeBell? Can you hear me?
Yes.
Hi, yeah, Guy DeBell, ex-chief engineer on the Royal Navy's PWR3 SMR. So yeah, so now in data centers. Yeah, no, NuScale, it didn't surprise me in a way because I think there was a bit of hype there. And if you've ever known it, I think Rickover's paper reactor memo is one you should read and have as a slide for all these presentations on the hype. Saying that though, the new nuclear military, Navy and American designs, which can be used for SMRs, I'm a big fan of long and thin water reactors, 100 megawatts or whatever. And, you know, and I've gone through 3 generations of nuclear reactors. When I saw what is capable now on the next generation of military reactors in terms of ductile steels, narrow gap welding, so, you know, really good integrity on your systems, the modeling. You know, 20 years ago, we were building proper simulators the size of nuclear reactors to test the reactors. Now it's all done on electronics, and it's done on virtual reality modeling. And the modeling is so accurate, you know. So I think I'm a big fan. I think I think there's a hype to get through, and I think NewScale and some of these others on your slide we're still a bit more hypey. But I think once you get through that and we can get into production environments and get some of these out there, I think it's going to change the way the public feel about them. And I've sat in enough public inquiries, I mean, hammered on nuclear reactor safety to know. Yeah, I mean, the other thing that amazes me about data centers as a whole, you know, you get a big data center, you might have 100 diesel engines in a row, each one costing £3 million. That's £300 million of assets that you only run a maximum of 30 minutes each a month. I mean, it's a ridiculous waste of assets. If we can move that towards nuclear reactors and have SMRs closely combined with data centers, I think there's a massive benefit there.
You know, I appreciate that. I mean, whether I look at the data centers or even some of the oil and gas operations, the number of diesel generators I see always boggles my mind. I'll say one more thing about the construction and design. I'll tell you what I look at when I think about some of what's going to make nuclear's deployment cost competitive and exciting. I'm less concerned about the nuclear part and more concerned about getting to the point where we can pour concrete and dig holes and lay steel in an efficient and cost-effective way. I mean, the large infrastructure part tends to bug me more than the actual nuclear part, which I think that's solvable. But I need a lot more repetitions to get good at it, because I think that's what tripped me up at Vogel, and that's what worries me with the new ones too. We can get there, and I know that a lot of the lessons learned that we're taking as the industry are focused on these balanced plant issues, as we call them. But it's something that we need to make sure we have the expertise and experience to efficiently deploy them, because they'll be true across technologies.
All right, Jeff, you have another question?
Yeah, thanks. So this is a large scale sustainability problem. So, you know, we're concerned about fossil fuel energy because of the greenhouse gas emissions, creating effectively a blanket over the planet, limiting our ability to reject heat from the planet. The planet's heating up. I'm real excited about the prospect of SMRs, and the thought occurs, SMRs or any nuclear reactor and fossil fuel plants as well probably produce twice as much heat as they're able to turn into electricity. So there's substantial heat production in addition to electricity production. And then, of course, all the electricity turns into heat as well. No matter where it goes, that's the only place power goes, turns into heat in our planet. So my question is, at the point at which the blanket around our planet is thickest, we begin to deploy heat-producing sources inside the blanket that don't emit carbon, because we've become very sensitive to increasing the thickness of the blanket. But we're doing that by putting more heat under the blanket, producing SMRs that are producing heat, no carbon, but a lot of heat when we have a thick blanket. Should we not be concerned about broad scale deployment of SMRs continuing to heat the planet?
So I haven't done this math in a long time, so I'm going to go off the top of my head. My recollection was I needed to deploy a stunning amount to be able to notice any of it. That essentially so much more comes from the sun. The amount of heat rejected from the steam cycle didn't rate for a while. But that being said, I think that there is a broader question about thinking about how nuclear fits in the broader economic calculation of what we're trying to think about as well, and how the technology can fit. So part of the appeal for the higher temperature applications is that they are more thermodynamically efficient and they reject less heat. But another thing that I think matters as well is how we look at water usage and for cooling, and the challenge that stresses there. We're seeing increasing efforts to have designs that don't rely on external cooling sources of water, instead have more air-cooled concepts. And I think that I only bring this up because we focus a lot on carbon, and I think for very strong reasons. But it is a lot that we're trying to solve for here. And I think there's a need for a mix of technologies that can help us fit across all of these dimensions. And that, I think, includes all sources of use cases as well. But it's a fair question, one worth considering deeply.
All right, we've got a couple additional questions still in the chat here. I think hopefully we can hit these relatively quickly and be respectful of everyone's time. Do you believe that if there's a change in the US administration that will disrupt the progress of nuclear developments?
We haven't seen that to date. The previous administration was very supportive of nuclear, as perhaps for different reasons. I mean, to the previous question, I don't necessarily expect that carbon will continue to be the main driver in that kind of a scenario, but the need for reliable power and as part of a global security engagement strategy, nuclear has always been well considered as part of Republican strategies as well. Honestly, it's been seeing the Democrats come to nuclear as a technology in the last decade that's been the change, not the Republican support for the technology.
And last question that we've got in the chat, as it currently stands, is are you seeing universities significantly engaged in the opportunities of nuclear power? And I'd broaden that to any other, campus type, behind the meter type developments.
So there are two things there. First, on the educational side, we do have a number of nuclear engineering programs in the country. They're growing after some years of decline. So we have seen, I think, the first stages of expanding the educational pipeline that we'll need to meet some of this demand. You also alluded to something else as well, which is that we are seeing universities that are looking to deploy small reactors to power campus operations, some of these micro reactors in particular, as a proof of concept. And so I think that we do have, I think, some very receptive university environments that we can build upon as part of the next stage for building the technology going forward.
I think you read into the question more appropriately than I did in terms of university programs on the education side. So are there any universities specifically which have more engagement than others in that realm with programs for students?
Well, I mean, we have some, just top of my head, MIT, Michigan. I'm on the advisory board of North Carolina State, Missouri, Purdue, Cal Berkeley. I mean, there's about 30 of them who have major engineering programs. Most of those have actual research reactors on campus that are operational for testing for students. Even MIT has a pretty big research reactor right in downtown Cambridge. Been there for decades. No one's noticed that it's fine.
Well, that's fantastic. And with that, I really appreciate everybody's time, engagement on the questions. Matt, thank you so much for your time and effort putting together the presentation, spending some time with us. Jansen, do you have any final comments or thoughts?
No, just thank you to Matt for his time. It's been a great insight into a subject that I think is going to be prevalent moving forward time and time again. I think, look into the UK side and see where we are there. It's interesting. It's just a interesting topic that everyone should be looking a little closer at.
My pleasure. I appreciate the opportunity to speak to you all.
All right,
Thank you
everybody
so
have a
much.
wonderful day. And if anybody has any follow-up questions, feel free to send them our way and we'll do our best. Cheers, everybody.
Thank you very much.
Good.